So in this lesson, we're going to continue with transformations of graphs. However, this time we're going to focus solely on cubic equations. So I'm going to kind of show you the transformations equation again and what represents what. There's a lot of things to know. The parent graph is y equals x to the third power, which means that's the most basic graph. When I start to add transformations, it's going to look like this one here, where you have a, b, h, and k. Just notice that the third power of 3 is there because that's a cubic function. Let's review what all these things are again. So a is a vertical stretch or compress. If it's a positive a, it's going to go up on the right and down on the left. If it's a negative a, it's going to go up on the left and down on the right. Because cubic functions are kind of like this. B is your horizontal reflection. Negative A and negative B will show you the same result. It's going to be the same type of flip. K is a vertical translation. And H is a horizontal translation. Your inflection point is this point here in the middle. It's that point of change of direction. So if you move it H and K, your new inflection point will actually be your H and K. Domain. Because there's two arrows going in all directions, your domain for these will always be all real numbers, and the range will also always be all real numbers. Or it can be written as negative infinity to positive infinity for both. And once again, that's because you have this image here, which means forever in this direction, which is forever in the right and up, forever in this direction, which means forever down and to the left. End behavior now. End behavior is referring to what is happening at these ends here. So as x is going to the right and getting bigger, my y is going up. As x is going to the left and getting smaller, so negative x, my y is going down, so negative y. So end behavior, if you have a positive a and a positive b, you get that x, as x approaches infinity, so let's kind of look at a picture here. As x is going this way, my y is going to, if we look, my y is going to be going up, which means my y is going to positive infinity. And as x is going this way, to negative x, or negative infinity, sorry, my y is going down, which will make that negative infinity. Now, if you have a negative a or a negative b, then it's going to be slightly different. It's going to look like this. So as x is going this way, my y is going down to negative infinity. And as my x is going to negative infinity, my y is going up to positive infinity. So that's end behavior, just talking about where's the end's going to end up. Let's go over a couple examples. Graphs should include 2 points on each side of your inflection point, which is hk, if possible. Use matching points for 2 of them. Graph the x values and work out corresponding y values. Think about which x value will give integer results. So for the parent function, easy numbers to plug in are like 0, negative 1, negative 2, 1, and 2. It's always going to work. So when you plug it in, my work would be negative 2 cubed makes 8, negative 1 cubed makes 1, 0 cubed makes 0. Sorry, this would be negative 8 and negative 1. Then 1 cubed makes 1, and 2 cubed makes 8. So we need to plot at least 3 of those. I'm going to start with 0, 0 because it's my point of inflection. I'm going to go 1, 1, 1, negative 1, negative 1. Then I'm even going to try 2, 8, and negative 2, negative 8. So you connect them. Now the inflection, since it did not move and it's my parent function, it's going to be at 0, 0. My domain, as we said above, is always all real numbers. My range is always all real numbers. And behavior, as x goes to infinity, my y is going up to infinity. As x is going to negative infinity, my y is going down to negative infinity. So now let's look at the graph on the right, which is the original parent function but with some transformations done to it. So now I need numbers that are actually going to work for this, that aren't going to give me too big. For example, if I plug in -2, the -2 minus 2 would make that -4 cubed, and that's going to be way too big of a number. So I'm going to start with just 0. Pick a number and see if it works. 0 would be negative times 0 minus 2 cubed. That would give me a positive 8. 1 would give me a positive 1. 2 would give me 0. 3 would give me a -1. And 4 would give me a -8. Now let's kind of see. This here means it's going to shift to the right 2. This here means it's going to be flipped, it's going to be reflected. So if I graph it, I have 0, 8, 1, 1, 2, 0, 3, -1, and 4, -8. Yep, it was flipped and it was actually shifted to the right, which means my new inflection point is going to be this number here as my h, 2, and 0, because k didn't change. Domain, all real numbers. Range, all real numbers. Now for this one, as x goes to infinity, what's happening to my graph? It is going down to a negative infinity. As x is going to negative infinity, meaning as the graph is going to the left, just put your cursor on there, keep going, it's going up to positive infinity. Going to look at two more examples. The third one, g of x equals 1/2 x cubed plus 1. We know that this is going to mean it's going to shift up. Therefore, my inflection went from 0, 0, 2, it's going to go to 0, 1. So here we can already know that just by the beginning. 1/2 means it's going to be shrunken. So we need to pick numbers that are going to make this work. You can always just try 0, 1, 2, -1, -2, and just see what works. If you feel like, you know what, these numbers are too big, then you're going to adjust accordingly. Maybe put some more numbers on there to show me. So my work would be 1/2 -2 cubed plus 1. That would give me a total of -3. If I go 1/2 -1 cubed plus 1, that would give me a total of a -0.5. When I plug in 0, I get 1. When I plug in 1, I get 1/2, or 1.5. And when I plug in 2, I end up getting 5. If I plot those points, 0, 1, 1, 1.5, -1.5, 2, 5, and -2, -3. So the shrinking part happens right in here. And you can notice that from here, this is like how big they are compared to how far spread out they are compared to not being spread out. Domain and range are always all real numbers. As x goes to infinity, my y is going up to infinity. As x goes to negative infinity, my y is going down to negative infinity.